Assalamu alaikum. This is Muhammad Abdullah. I am your course instructor of the microprocessor systems. In this video, I am going to discuss some introductory topics to understand the basics of this course and what to expect from it. First of all, the recommended textbook is this one. This book includes introduction to embedded system, assembly programming, and the interfacing of microcontroller with different peripherals. So here we are going to discuss these topics here: embedded systems, microcontrollers, memory, the microprocessor architecture, and the performance comparison, system development tools, and debugging. First of all, what is embedded system? Embedded system is a microprocessor or a microcontroller based computer hardware system with software which is designed to perform some specific tasks. It can be a standalone system or it can be a part of a very big system which has been divided into multiple embedded systems of a small kind. Complexity, it can be a very simple input or output system, or it can be a complex where we have image processing and different kind of digital signal processing aspects of it. So history of embedded system. First embedded system was developed by Charles Stark Draper in 1960 for Apollo guidance computer, which was used in moon landing. The first microcontroller was developed by Texas Instruments in 1971. Another microprocessor very famous is Intel 4004. Importance of embedded systems can be realized by seeing the future trends in embedded system. First one is automation. Automation is being used to automate different processes in industries and control systems. Second one is artificial intelligence. AI has taken the world by storm and it is disrupting our lives now. Embedded systems infused with AI is bringing huge changes in image processing and other fields. Third one is machine learning. Machine learning trained systems can make fast and better decisions. Automobiles industry has been revolutionized by embedded systems. For example, self-driving cars and park assist technologies are introduced now in cars, and smart interactive systems are also being placed in automobiles. System on chip is a single chip with memory, digital signal processor, and every peripheral on a single chip. Example of this is Apple M1 and M2 chips. Internet of Things is a concept where everything is smart and connected to the internet, so it can be controlled through the internet. VR and AR technologies are also being advanced through embedded systems. An embedded systems has basically two parts. First one is software and the second one is hardware. For inputs from the user, interfaces of different kinds are used. It can be a button, a keypad, or different kind of sensors. The system processes this input and gives output through output interfaces, and it can also send these processed data to other subsystems to perform different kind of actions. Basic structure of an embedded system. Input data is obtained through sensors. For analog data, it is processed through analog to digital converter before sending it to the processor and ASIC. For digital data, this step can be skipped and data can be fed to the processor and ASIC directly. Then processor and application specific integrated circuit performs actions according to the program, and this data after conversion through digital to analog converter is fed to actuator. Actuator then applies the necessary changes. In this whole process, memory is used to store data and variables. Types of embedded systems. Embedded systems can be divided into two types. First one is based on performance and functional requirement. The second one is based on performance of microcontroller. The first type of performance and functional requirement is real time. Real time system is based on the real-time input by the user, and the decisions are made in real time. Second one is networked. In these, subsystems are connected over a network, and the inputs and the process data is shared over multiple systems. Third one is a mobile embedded system. It is a very small system which can be moved from one place to the other. The last type is standalone system, which is designed for our very specific application only, and it performs that task over and over. The types based on performance of microcontroller are small scale, medium scale, and sophisticated. These types are based on the scale of the system. For example, small scale systems can be in a specific place, whereas medium scale systems can be network systems placed over multiple places. Sophisticated systems are very large scale, for example, the communication systems of a company. Examples of embedded system. Embedded systems are everywhere around us. For first example, there is an automatic washing machine. So the microcontroller takes input through this dial from the user, where user can select different modes and different timings for the wash. Here the data is displayed so the user can interact with this dial and understands what's going on. So the drum speed and operations of this machine are controlled through the inputs given by the user here. The elevator is an also example of an embedded system. So there is a controller installed in it, and there is a panel available where you can select the floor where you want to go. So here is an example of a very large scale sophisticated system, which is a communication system and an example of Internet of Things, where every device is connected to the internet and can be interacted with. A modern drone camera is also an embedded system, which can also track you, and it can have different modes of operation based on the mode selected. So it's also an embedded system. These are the design metrics of an embedded system. Every embedded system is designed keeping these crucial points in mind to ensure the stability and security of an embedded system. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes microprocessor, memory, and input-output peripherals. Also, it includes communication interfaces to communicate between inputs and outputs, and with the memory and timing interfaces. Different types of MCUs microcontroller units are manufactured by different manufacturers. For example, this is an STM32F407 VGTX board developed by ST Electronics. This is developed by Texas Instrument, and this is a very famous MCU Arduino Uno. Storage space is required to store data and programs that are currently being used by embedded system for processing. For this purpose, memory is used. So memory is referred from the memory address, and we can store data at this location by using that memory address. So there are two types of memories: RAM, random access memory, and ROM, read-only memory. We can write and read at the same time to a RAM, but ROM can be written once and it cannot be modified during the processing. So once a program is stored in ROM, it cannot be altered during its processing. There are two main types of RAM. First one is dynamic RAM, DRAM, and the second one is static RAM, SRAM. DRAM is widely used as computer's main memory. Each DRAM memory cell is made up of a transistor and a capacitor within an integrated circuit, and a data bit is stored in the capacitor. Since transistors always leak a small amount, the capacitors will slowly discharge, causing information in it to drain. Hence, DRAM has to be refreshed every few milliseconds to retain data, whereas SRAM is made up of 6 to 4 transistors. It keeps data in the memory as long as power is supplied to the system, unlike DRAM, which has to be refreshed periodically. SRAM is much faster and also much expensive than DRAM. ROM can be divided into multiple types. First one is programmable ROM, which can only be written once and its contents cannot be changed after. Second one is erasable PROM, which uses ultraviolet method to erase data. Third one is electrically erasable ROMs, which contents can be erased electrically. Fourth one is flash, which is also a type of double EPROM, but it is much faster and its architecture is different than double EPROM. A microprocessor, also known as central processing unit, has capability of executing instructions at an extremely high speed. It is basically brains of our MCU and it contains data processing logic and control. Components of microprocessor. First we have control unit, which sends digital signals to operate the other components. Second one is timing unit, which provides us clock. Third one is program counter, which stores the address of the current statement being executed. Arithmetic logic unit performs arithmetic operations. Register file is used to store information after and before processing it. Working of microprocessor. Microprocessor works on the principle of fetch, decode and then executed, and these steps are repeated after each other. First one is fetch. The control unit will fetch the data stored in memory and it will tell the instruction to be executed. Here we have sum of two numbers. So the second step, the control unit will send instruction to the ALU arithmetic logic unit to perform summation of numbers stored in register 1 and register 2. Then ALU will perform their sum and then it will be sent to the memory for the execution and the results is stored in an register. Then again, if more instructions are given, then control will perform again fetch, then decode and then execution will be performed. Thanks for watching. Don't forget to like, comment, share and subscribe to our channel. Thank you again.